Good morning, Yakima. So here I'm here to present our 5-year study that we did in Pierce County with our IDDE data. I'm not going to explain to you what IDDE is because you're all stormwater professionals, and I promise I won't subject you to any gross IDDE discharge photos. It's a little too early in the morning. I do have a lot of those, but not in this presentation. So I was at Federal Way, City of Federal Way for 14 years, and I started with Pierce County in November of 15, and when I went down there, I was in charge of the IDDE program, and I found that they had a whole lot of data that they were collecting, and it was collecting virtual dust. You know, nobody was doing anything with the data, and I thought, this is a great opportunity to really do something with it. And I don't think any other municipality across the country was even diving in anything like this. So it took me about a year to put all this together. And so it's a great opportunity here for me to present this data to you. There's a whole lot of data I crunched, so I'm just kind of giving you the cream of the crop of the analysis that I did. And I think it's important to note that, you know, IDDE incidents that we record is only giving us a picture of the stormwater pollutants that get into the environment. There's a whole nother universe of stuff that we don't know. So this is just representing what's reported to us. So, but it's interesting because it does correlate with a lot of what we do know, all the other data that we collect that impacts our watersheds and stormwater and so forth. So here I go. So the project goals here was to create a robust 5-year IDDE database that it went back from 2012 to 2016. And I was hoping to determine what the pollutants of concern were, how to establish some trends if I could, identify problematic watersheds, and help understand program functions and efficiencies. The important points here that I want to share is that the study was done in-house. There were no consultant fees. I just kind of worked on this as I could throughout the year. And it's also important to note that this is really specific to Pierce County. You'll see a lot of the slides will show how these data correlate directly to what we do at Pierce County and directly to the watersheds in Pierce County. So it's a complement to, if you're familiar with the site or the source identification and diagnostic repository, that's a permit S8 monitoring requirement under both the phase 1 and the phase 2 permit. So I think it's a complement, or it could be an alternative. It could be a prototype for what other municipalities could implement. So Pierce County is growing very rapidly. If you saw in the news recently, the US Census came out and said that Pierce County was the fastest growing county in the US for people moving in from other counties. So it's really growing fast. We've got 380,000 people, 1,800 square miles, about 1,800 miles of MS4. We have, you know, everything from the foothills and streams of Mount Rainier through pasture lands in the lowlands, Puyallup River Valley, Nisqually River Valley, shoreline, islands. So we have a whole different set of land uses that really lended itself well to this study, and it's just, Pierce County is just kind of like a petri dish for an IDDE study like this. So going back, the existing record-keeping system in the county is a web-based system. It's similar to maybe what other jurisdictions are using. There's a pull-down menu. It was originally used by Rovertops, and it was adopted by SWIM. So we have what we have, and there is no plan to move to a more sophisticated system. But it records basic information But it's got limited functionality, it's clunky, it's really hard to get the data out of it. So I had to think of a better way to do it. So what I did is I created an Excel database that we could use pivot tables and make it really, really powerful. So there were basically 5 or 6 data components that were collected in the system, and I almost tripled it by adding a whole lot of other data, including the pollutant type, the drainage basin, land use, and so on and so forth. So then I could really kind of make this thing work and see what kind of information I could get out of it. It's important to note that at Pierce County, we have 2 different components of IDDE investigations. One is done by the SWIM group that goes out and just responds to complaints that you get over the phone, out in the community and whatnot. Like this is an example of a paint discharge into a ditch and a lot of other things going on here, and then they do their investigation. The other component of IDDE at Pierce County is Rovertops. So they will respond to incidents that occur in the right-of-way, spills, and things like that. So this is an important distinction as I go through the data and the information. So when we look at this, when I look at all of the data, and there were over 1,000 different incidents through this 5-year period, I've got kind of a Heinz 57 of different types of discharges, from sewage to yard waste to cooking grease to herbicide to algae, everything. And it's important to put these into its proper category. I didn't want to have something categorized as sediment, mud, dirt, or something like that. It's got to be in the same category in order for you to be able to search for this data. But one thing that really jumped out at me was this: over a quarter of them were unconfirmed. And unconfirmed is what I categorize as when an IDDE incident response is initiated, and upon inspection, the reported pollutant or concern could not be located or validated by the investigator. And here you see the SWIM crew, when I break it out between what Rovertops does and what SWIM does, 38% of SWIM, they're going out and they're not finding it. And this should be kind of familiar for you folks that do the IDDE. You may get a call and somebody says, hey, there's a discharge out here, and the person that goes and investigates it can't find it, or they go out there and find out that it's iron bacteria discharge, or maybe a rain event had occurred and it took a day for you to go out there and it wasn't there. This is concerning for Pierce County because Pierce County is rather large, and it may take a half an hour or so for a crew member to go out there, and they go out there and it's kind of not fun when you can't find it. Rovertops here, it shows you that 95% of the time when it's a reported spill or a leak in the right-of-way, they're going to find it and it's a valid complaint. So this is kind of a good data that was uncovered by this study, and I can keep track of this and see if I can improve that 38%. And when I look at it through the years, it's going down slightly, but the data shows that that's about what we got to live with so far at Pierce County, that there's a large percentage of these unconfirmed. So as I keep this study going, I'm hoping to improve this and get it down a little further than that. So one thing I wanted to do was combine the petroleum constituents into one. And on one hand, it was fortunate that the Rovertops crew and others, when they're doing their record keeping, when they respond to a hydraulic spill, they call it a hydraulic fluid spill. And when they recognize that it's a tranny fluid, that goes in the record, or if it's gasoline or diesel. But I wanted to combine them all into one and just call it Petroleum. So for purposes of this study and the presentation here, and this doesn't include unconfirmed responses, is that Petroleum is king. Those are that's the number one type of pollutant that we see for IDDE discharges, and I think this kind of corresponds to a lot of other stuff that we know. Because of transportation issues and things like that, that's just the number one pollutant that we have to battle with. Sediments up there. Unspecified is a pollutant that we may respond to. It may be a milky discharge in a ditch and we don't know what it is, so those all got lumped into unspecified. Then we got paint, private septic sewage on down the line, and then we track livestock issues too, because out in the rural areas that can be problematic. Here's something that ties in directly to the permit requirement. There's a permit requirement that says that the average number of days to initiate a response, it has to be 7 days. So this data directly shows us how we're meeting permit requirements. Blue is swim and it's tracking down, but it's up around, let's say, 1.4 days. On average, this is Rovertops and swim, it's 1.33 days, and Rovertops hugs right at 1, so 1 day, because when they go out, they get a response, they go out and they're out there within hours probably. Another thing I looked at was how many days did it take to resolve the issue? So I can track that through this data analysis that I've done. Blue in swim, it's going down, so that means they're getting better at resolving these issues. In some years, they had some probably tougher nuts to crack, and it took upwards up to an average of 20 days to resolve the issue. But there again, Rovertops, they're really quick. They may have to go back out a day later and throw some more pads down or absorbent material until that issue is resolved. So what I wanted to do also was to see if there's a correlation between rainfall and IDDE incidents. As we know that stormwater does a great job of transporting or making pollutants more visible to the community. So black is the 5-year rainfall data through 2012 to 2016. And you can see the usual Western Washington drought that we have in summertime. And then also with rainfall, the last 5 years, we get this little blip here around February and March. And when I do this for next year and add 2016-17 data, I'm sure we all know that we've had a really wet early spring, late winter, and this bump is going to go up. So I looked at this, I thought, okay, I can believe that the IDDE incidents, which are in blue, are less prevalent in the summertime, because let's say you get a leak in the right-of-way and a few drops of oil on a rainy day. You're going to get a ton of calls because that gets picked up, the sheen turns into a big rainbow slick and it runs down a couple blocks and people call and you go out and respond to it. In the summertime, you might get drops on dry pavement and nobody calls. So, and the same thing with sediment and other pollutants, like let's say private septic systems, when the groundwater rises, you're going to get more incidents of this stuff surfacing and you're going to get calls. But what was curious to me was, why were there so many incidents that almost mirrored the rainfall during that period of time? And so I looked into it. What is this big blip? I didn't know what that was. So when I presented this to my crew, they go, I know what that is. That's when the Rovertops crew, when they're actively doing their spring assessments and catch basin cleaning of the system, that they're actively looking for discharges. And in the past, they call us all the time during March and April. So I looked into this, and then when I spread it out over the year, yeah, there are some recurring spikes that were occurring every year, the same time of year, especially these three, and then to a lesser extent over here. So then I dug into it a little bit further, and I could tease out when, through the information that we collected, through the narrative of what were these incidents that did come as referrals from road ops, and nearly a third each year were occurring from when road ops were calling us up and saying, hey, we have an IDDE, we're doing cleaning, and we're seeing foam in here, come check it out. We're seeing some weird stuff in here, come check it out. So that's a good thing. It directly correlates to field screening. So, but I didn't know how to explain why, they didn't call in during these years. So when I presented this to road ops and I said, hey, what's going on here? You guys used to call in a lot and now you aren't. Well, guess what? I'm starting to get a bunch of calls now. They want to try to get that back up. So when I run the data next year, I bet you that I'm going to have another spike coming up. So it's just a really good visual of how internally how your program works. So here's something important. Where do these responses originate? The majority of them come in through your, people calling me, emailing me, passing me Post-its in the hallway, saying, hey, Dan, there's a discharge out there, Though that's the majority of them. Other ones, 23% are coming from either internal or external referrals, either from, let's say, our source control program, ecology with ERTs that I'll get, Pierce County Health Department, our water quality monitoring group might see something and they let me know there could be a discharge. And then field screening. This is the road ops field screening was the biggest chunk. And then we have another field screening element that we do that satisfies that. So this is permit required, and visually we see that. But this just gives us an idea of where do these incidents come from. A couple factoids that are just probably insignificant, but they're kind of cool to me because these are the little things that I can really dig out of this data. 2% of the time we'll get calls and we'll be running around because people will see flows coming out into the curb line or into a ditch and they're concerned and worried, but we'll go out and we'll see, is it, we may do some testing to see through our ordinance, is it contaminated or uncontaminated groundwater? And then we always have these pesky iron bacteria. People think that that's an oily sheen and they'll freak out, and then we'll go out and find out that it's not. So let's look at road ops a little bit. They're responding to accidents in the right-of-way. So again, 80% of the time it's petroleum. That's not a big surprise. So then I thought, well, this is interesting because the narrative that they have, the great record keeping that they have, they describe what these incidents are. Are they leaks in the are they responses to the right-of-way spills, or are they also record their own equipment when those leak, like a hydraulic line from a brush cutter might blow in a ditch, and they respond to that. So I thought this would be interesting to find out what percentage it is and a little bit more. So 61% of the time, the road ops crew their IDDE is response to right-of-way spills, and 39% was responding to their own equipment. So when I look at just right-of-way spills, 2.8 average per month that they're responding to, and the numbers are, the trend line shows that it's slightly going up. So this could be that, you know, people are reporting these spills more often because we're doing a better job at educating people that, you know, we're here to respond to these, pollution is out there, give us a call. Or it could be that we're just dealing with more and more people, more and more cars, and the trend line's going up. When I look at Rovertops equipment leak trends, they're responding to an average of 1.8 of these incidents per month, and Rovertops got real happy when I showed them that the trend line is kind of slightly going down. And this could be a reflection of better BMP, the preventive maintenance, that they keep better track of their equipment, and these incidents are not occurring as frequently as they were back in 2012. So now let's go into watershed analysis. And I thought, well, okay, this is really above and beyond of what CIDR might be able to do for the region, but this has really given us great information that directly relates to what we do at Pierce County. Pierce County, so I decided to focus on 26 sub-watersheds that go from the White River, Puyallup, Carbon River, the Nisqually River, and on down. Like I said before, we've got a whole lot of different land attributes across the county, from the mountain, the foothills, the lower area where you have a little bit of farms, some hobby farms, small streams. In this area, if you're familiar with Pierce County, it's more congested, Spanaway, Parkland, Pacific Avenue. It's getting bigger, more dense. There's a lot of commercial strip operations, and the white is the incorporated areas like Tacoma and Puyallup. So this is the analysis that I did on the watershed. So the mapping feature in the RMS system that's currently being used is not that great. So this is about the best I could do. And my hope is that in the future, I'll be able to assign a lat long to all of these data point, and then we can put these into our GIS system. But what this tells you right here is that the number of incidents that are occurring where people live. It's all concentrated right up here. I don't know what this one is way out here on the near Mount Rainier, but this is just a visual indication that pollution occurs where people live. So when I mapped the density, I had to think about comparing apples to apples. So I'm not going to just say one subbasin had a larger number of incidents, therefore it was the worst. Well, that subbasin just may be bigger. So we have to look at density. So you have to normalize the data, and I plugged them into 4 different ranges from greater than 10 incidents per square mile, 5 to 10, 1 to 5, and less than 1. And then I colorized them, and you can see red is the worst, and red and orange and yellow are where the people live. So this is a simple illustration of where these IDDE incidents occur. And so you can kind of like see it mirrors the same as what was in the mapping under the RMS system. So I want to go a little bit further. Well, here's another representation. So all of the 29 basins, you can see that red is the worst, and that Chambers Bay was the worst. Hylebos Creek was second. Clover Creek, Clear, Clarks Creek, Gig Harbor, Mid-Puyallup, and down the line. But unfortunately, Chambers Bay and Hylebos Creek, these numbers are just based on a small population of data. And so I wanted to concentrate on those basins, the top 4 basins that had the highest number of incidents because the data was more robust. So there were 4 basins that made up nearly 3/4 or 75% of all the data that we had. So I wanted to look at Clover, Clear, Gig Harbor, and Mid-Puyallup. So when you look at those, it's a direct correlation. Here we got the number of incidents per square mile, and Clover Creek is the mostly dense, mostly populated subbasin. It's got the greatest number of incidents, it's got the greatest percentage of impervious, it's got the greatest commercial and industrial land use categories, it's got the greatest percentage of road miles, and then conversely, it's got the least or nearly the least amount of undeveloped land use, and Mid-Puyallup has got the greatest undeveloped percentage of land use, but then it's got the least of these other 3 over here. So when I graph these out, we got great correlation here, a great straight line linear correlation between here's IDDE versus impervious for all of the data that I had. And then if I just look at petroleum, it's got a great correlation there. More petroleum IDDE incidents occur in those areas that have the greatest impervious areas. The same with IDD, total IDD and road mile density. It's a straight line. It goes up. Commercial industrial, the same. It goes straight up. Undeveloped, it gets flipped. So the least or the most undeveloped areas have the least amount of IDDE incidents. And then I went in, and then so I'm just going to share with you a couple different subbasins that kind of contrast a little bit. Here's Clover Creek, Steelicombe Basin, and it is located right here in Pierce County. It's got the aerial photo will just show you it's just all gray with not much vegetation, a lot of parking, a lot of roofs, a lot of streets, a lot of impervious. So when I broke that out, petroleum is number 1 for Clover Creek, a little bit of sediment, some unspecified paint. So I can just continue this, crunching this data through the years as we go, and just to see if there's a change. Then when you look at Clear Creek is situated here in Pierce County, but it's got a little more green. There's a little more rural area in Pierce County. There's some small streams, more farmland, more little hobby farms, less commercial. And when you look at the data here, we see that sediment is a bigger, petroleum's still number 1, sediment's starting to creep up. We got some more private septic issues out there, and then livestock, as we track those, begin to show up in the Clear Creek area. And then lastly, I wanted to kind of tie into TMDLs. So TMDLs, we've got 3 active ones in Pierce County right now. We've got the Clear Creek TMDL area, Clover Creek, and South Prairie. So let's look at Clarks and Clover. So this is important as we move forward to identify pollutants of concern and reduce those inputs in our TMDL areas, how IDDE data can become a part of that equation. And so Clover Creek, the listing is for fecal, coliform temperature, and dissolved oxygen. And here we have pet waste and private septic and sewage that I can track in the IDDE program to go toward helping inform the TMDL process in Clover Creek. And then for Clarks Creek, although there's only 14 incidents that I have here, pollutants of concern is sediment and fecal and dissolved oxygen. So we have sediment as showing up here, private septic, and livestock issues down here. So in closing, what's the value of this study? Well, it lays the groundwork for other municipal MS4 programs. So it's kind of, like I said, the site or prototype. It identifies pollutants of concern, trends, problematic drainage basins, and this is a watershed approach, which is something that we should be thinking about more. It confirms the relationship between stormwater pollutants and land use, imperviousness, road mile densities. It effectively organizes an IDDE database for additional future study. I can just keep rolling on this in years and see if the trends continue. It improves our IDDE record keeping under the permit requirements. TMDL, I explained that, how it can be tied in with that. It can assist in prioritizing CIP investments. This is interesting. It empowers IDDE staff. Before, they just maybe not really had a clue as to where they fit in with the big picture of things, and now they really see that, yeah, this is what I do, and this is, I can see a lot better what I do. It provides public information concerning what the swim utility does. It's your tax dollars at work. It complements public education programs like Don't Drip and Drive. So this is the petroleum element of that. It promotes stewardship within watershed councils and the community. And then it can provide additional supporting data for water quality grants. So I appreciate having the opportunity. And if there are any questions, I'm here to answer.